Hello Internet, welcome back to Daily Codes. Today we are going to begin a new project. I'm very excited for this project. I think I'm always excited to do new projects and then when I reach midway there, I kind of get bored of it if it takes longer than a month. But today, hopefully this project is not going to take a lot of time. We are going to do loan default prediction, and the data we are getting is from Kaggle. Please visit, the link is on the description. You can go and get the data here and also give them the credit that they deserve, because they're the ones who provide us data, and getting data is very hard from these institutions. So we are going to work on this project, and the project is about vehicle loan default prediction. There is a company somewhere that gives people vehicles on loan and then they pay back, but some people default, and they want to be able to identify people who are going to default when they're given the vehicles forehand, so that they can see how to mitigate the risks of giving out the vehicle. So we can read the description of the data set. They're saying financial institution incur significant losses due to loan default vehicles loans. I don't know where my head is. Anyway, let's read this. Financial institutions incur significant losses due to the default of vehicle loans. This has led to tightening up of vehicle loans underwriting and increased vehicle loan rejection rates. The need for a better credit risk scoring model is also raised by this institution. This warrants a study to estimate the determinants of vehicles loan default. Financial institution has hired you, that is me and you and anyone who is going to do this project. So a financial institution has hired us to accurately predict the probability of a loanee or a borrower defaulting on a vehicle loan for the first EMI, and EMI is equated monthly installment on the due date. The following information, blah blah blah. So at least from here we understand the mission of this project. There is a lot you can read about. I think I've read this like 5 times before I started recording. You can get the link to this in the description and download the data. We are going to create the project. The code, you'll find it in GitHub. I'm going to create the GitHub repository after this, but the data will not be there because the data is not mine and I cannot share the data widely throughout the internet. You'll just find the link to this post and you'll find the data here. Yep. So let's start the project. I'm going to go to GitHub, and we're going to create a repository. It's good to create a repository so that you can not profile, I should be project, so repository is here. It's good to create repositories so that you can be able to either share code or collaborate in all the projects that you're doing as a data scientist or a data engineer. Okay, so let me make this bigger so that you can see it. Then we create a new repository, and I'm going to call it this. The scope of this video is just to do the data cleaning. Then the next video we're going to do the machine learning. Yep, but we're going to set up the project now, then we do the data cleaning. I'm going to call it that. I'm not going to put a description now, and I'm going to make it public. So I'm making it public so that when I share with you the link to the repository, you can see it easily. Then readme, I want it to have a readme just in case we need to put information for people to understand about the project or repository. Then the git ignore should be Python. We're going to majorly use Python. I don't know if we'll use JavaScript. Yeah, and I'm not pushing anything to production now, so the code coverage and Travis CI. Not now, but later maybe when we are working on this project. So what data scientists majorly do is to create the machine learning model and stop there. But for the purpose of this project, I want to do end to end. I'm going to clean, do machine learning and all the other stuff that comes with it, feature engineering, feature selection, machine learning model selection and comparison, all that stuff. Then after that, when we have an optimal model that we want to use, then we're going to try to serve the model maybe through an API. And if you are loyal follower of this channel, you know that I like using fast API, but you'll never know. Maybe I may use some other framework, Python framework for creating API. But most likely it's going to be, we're going to serve the model using fast API. But the scope of this video is just to clean the data, because cleaning takes so long, and I know this video is going to take so long. Yeah, but you can watch it in phases until we finish. So we have this, and we can clone it. So I'm going to copy. I'm not cloning with SSH. I'm going to clone it with HTTP. Did I put my SSH key here? I'm not sure if my GitHub has an SSH key. So let me clone it with HTTP. I'm going to clone it in my documents. So I'm going to seed into documents. Then I have a folder for my YouTube projects. Then here I'm going to clone it. Git clone. Hopefully it will clone there with the HTTP. Yep. So it is L minus T. So cd L. Yep. So here is where our project is. I'm going to use Python 3.10.0. So I'm going to use pyenv. If you don't have pyenv, you should install it. Pyenv local. So pyenv is used to manage my Python versions. 3.10.0. Okay. Then I'm going to create a virtual environment. So Python -m venv venv. I'm not a fan of conda. I think when I was young and I tried to use conda on a certain machine, I failed to use it, and since then I've been using pip, pip and the virtual environment, the Python VM virtual environment. So let's activate this virtual environment. So VM bin activate. Yep. So we have this. What is inside here? It's the README and the virtual environment. What is inside here really is, yeah, so we have a Python version, we have the git ignore, we have the git repo, we have the README, we have the VM. So this is how far we've gone. So we are going now to install relevant packages for data cleaning, and the packages that I'm going to install, several of them. So it's going to be pip install, then I'm going to install pandas, then I'm going to install plotly for analysis. We're doing data cleaning, so we'll need several visualizations. Seaborn maybe. Seaborn. That is spelling of Seaborn. Can't remember. I think like this. Then matplotlib. I think it comes with Python nowadays. I'm not sure, but we shall try and see. NumPy comes with pandas. I think that's what this is all we need for now. Yeah, we shall need Jupyter, so we'll use Jupyter Notebook. I prefer using Jupyter Lab, so I'm going to install Jupyter Lab. Jupyter Lab as one word. Yeah, I think that's all. So let's install this. It's going to take some time to install, so I'm going to pause the video here and then I come back when the installation is complete. Well, the installation is complete, and now what we need is to download this data. So I'm going to data, it is 12 MB. I'll click on here and I download. It's called archive1. It's here downloading. Then I'm going to archive1 in my downloads. Just checking downloads on another screen here. Yes, so I have here archive1. I'm going to copy it. Then I'll go to documents. Inside YouTube there is LNT. I'm going to paste it here. Then I'm going to unzip it. I'm going to move this to trash because now I don't need it. Then I'm going to rename archive1 to data. Then inside it we have this. Right, I'll go back to my documents, my downloads I mean, and also delete this. Okay, so let's launch VS Code. I'm launching VS Code so that I can open gitignore. Let me make this bigger for you to see. Yeah, I'm launching this so that I can open gitignore so that I don't push the data to the repo. I don't want problems with Kaggle. Okay, so anything that ends with .csv should not go to the repo. So we're going to have inside gitignore here. $ignore CSV datasets. Then I'm going to put star.csv. Yeah, so they all turn black. So anything that ends with CSV will never go to the repo when we do a git push. So that's nice. Let's now go to the terminal and then we fire Jupyter Notebook. I think in one of the videos I'll show you how to use Jupyter Notebook on VS Code. But now let's use Jupyter, just Jupyter Lab. So we installed Jupyter Lab. Let's use it. Jupyter Lab in the terminal, and I want it to fire from here. I have several browsers open. Yeah. So let me make this bigger. You can see several stuff here. Unless you're a psycho, you should, I don't think you'd like to use a white background or a white theme with Jupyter. So I'm going to change this theme to dark. Yeah, so this can help me to work long hours. Then I'm also going to say auto, there is something I need here so that it can automatically close brackets and quotes. Can't remember where. Right here, view to somewhere, I think in the to save your file, close, yeah, auto close brackets. Nice. So let's create our file. So it's going to be a new notebook, and I'm going to call this notebook data cleaning. Data cleaning. So it's a data cleaning notebook. Then I'm also going to create another notebook, just like previous project that we've been doing, that will contain our libraries or functions that we use in data cleaning. Libs. The reason why I do this is because after you have trained your model, you will need to push your model to production, and the data may be coming in the format, the raw format that you had before you clean it, and you'll need these processes of cleaning also embedded in the in the code that is in production. And if you just write code and you don't think about how your data is going to, how your product in this case is machine learning, is going to be consumed, then it's going to be very hard for either the machine learning engineer or the data engineer or someone working with the DevOps to be able to serve your model, because they will not be understanding your thought process. But you can make their work easier because you're working as a team. To whenever you're cleaning your data, you'll be thinking about how the model will be used, will be consumed by the users. And that is what is always on my mind as I'm cleaning. I say, okay, so when the data comes like this, maybe at an API, which function should it call so that the function can clean it before the data is passed to the model for the prediction. Yep. So that, and we are now going to import the data. The data looks like this. If you use Jupyter Lab, you can easily open and have a quick look at the data set. Right, let's import the data. So I'm going to use pandas, import pandas SPD. I don't know, I'm not familiar with other packages that I use to manipulate data, do data wrangling, apart from pandas. If you have any idea of another Python framework or Python package that can be used to do data manipulation, just like pandas, please share in the comments. I'll be very happy. Also, talking about sharing in the comments, I'm going to shout out guys who participate in the comments at the end of the video. Yeah, so that we can motivate us to be more active with the channel. So import pandas. Then our data is going to be pandas.readcsv. And then the path. It's taking so long to import. I don't know why. Yes, so it is in data. Then it's in, we're going to use train data, because test data is for Kaggle when you're making a submission. So we're just going to work with the test data. Then let's run this. Then I want to look at the data. I want to first look at what's null. So we're going to import some things here. Since I want to plot it with the Seaborn, I'm going to import Seaborn. What I want to do now here in this cell here is to identify missing values. We're doing data cleaning. So we're going to import Seaborn. I know you can do data dot is na dot sum, and it will give you the sum of missing values per column. It seems it's only one column that is having missing values, but I want to do this graphically, so that's why I'm going to use Seaborn. So import Seaborn CSNS. Then I want to the grid of Seaborn to be a white grid, so SNS dot set style. I want the style to be a white grid. Then yeah, let's, instead of doing this, I'm going to do I also need plotly. Sorry, I import not plotly. I need yeah, pyplot. I mean, so pyplot is gotten from matplotlib. Dot pyplot as plt. So let me run this. Then I'm going to set the size of this figure will be plt dot no module named matplotlib. It's okay. So we're going to install it from here. If you want to install something in Jupyter, you don't need to go and like close the session of that is running here on the terminal. You can easily just install from here. Just begin with the bang. You begin with an exclamation mark, then you say pip install. Then what we're missing is matplotlib as a package, and I run it. So as it is installing, it's saying that it's pyplot. I was wondering. Oh, nice. Let me remove this. So plt, we are setting the figure size dot figure, and the size of the figure size should be equal to I want the width to be 20 units and the height to be 5. Then let's plot a heat map. So seaborn.heatmap. And want a heat map of data dot is null, so that it gives us the truth values of null value. Then we don't want y tick labels, so y tick labels, I don't want them because they take so long. I also don't want characters, and I want my column map to be viridis. I don't know how to pronounce this. Then let's show this chart. plt.plot. Run this. So what is the problem here? Unexpected white tick labels. I'm trying to look at where the problem could be. Let's check the site. Seaborn.heatmap and confirm the argument is called white tick labels. I'm going to copy it and I paste it here. Then run this. Unexpected argument ch. Could it be the space now? Let's check here. Do they have that argument? It should be C bar. Sorry. Run this. Yeah, it's going to show here somewhere. Yeah, so this shows us the same thing that we discovered before, but in a graphical way. The yellow lines show the missing values, then the purple shows field values, and you can see that we only have yellow lines from implement type. I prefer visually looking at this than looking at the number. So let's look at this data further. We know that implement type is missing. We shall handle it when we're handling implement type. Let's look at the description of data. So there are several ways of looking at the description. Describe, and mostly I do the describe to show me the maximum and the minimum values, and also show me some percentiles, and this will help me know if I have extreme values. For example, let me just look at this. What am I pointing at here is 50. So this is the median value. Now when you look at this, for example, the 75th percentile is 0, but the maximum value is close to, it's above like 4 million or something. So this could be an extreme value. The same as this, you're seeing that the 75th percentile is this, but the maximum value is 35. So we have several values here that have very extreme values. So this is one way. There is another way that I use to describe the data so that I can get more info, and it uses a package which we forgot to install. It's called pandas profiling. So let's first install it. Pip install pandas. It is pandas underscore profiling. it takes long to install, I think, and it also takes long to run. So I'm going to like pause the video here, and then I come back when it has finished installing. It has finished installing, and now we can use it. So we're going to do pandas profiling and then the data. It is also going to take a lot of time to profile the data. So I'm also going to pause the video then and wait until it completes. But when I run this, oh, I have not imported it. I'm going to import it up here. Import pandas profiling, run this. So now we're just we are just exploring the data. So I'm going to run that to import pandas profiling. I'm seeing a warning here. Please update Jupyter API widgets. Okay, I need to install this so that it is updated. I'm going to stop the importation. I'm going to do a pip install API widgets. Yeah, okay. So when we import this again, also I'm running automatically the cells using Shift Enter, but you can always click on this run button. I'm going to cut that. Yep, it's complete. Then we are going to run pandas profiling. Module object not callable. How do you run this? Oh, it is called pandas profiling. Let's profile the report. Profile report, because we want to get the report of the data. Run that. Yeah, so this is the one that I was saying that is going to take a lot of time to complete giving us the report. Sometimes it takes like 5 minutes. It depends on the size of the data and the number of features that you have in your data set. So I'm going to pause. You will not know that I've paused, but until it completes, then we shall be looking at the report, and the report will give us a lot of insight about the features in our data that will help us to continue with the EDA and the data cleaning. So I have gotten an error here, and I've just remembered why I have this error, and I think you people should also know why I should have this error. It's saying that I cannot import check save fig extra arguments from matplotlib backend basis. This happens when you install pandas profiling package and you don't restart your Jupyter environment, so it will bring this. So what I'm going to do now is to restart Jupyter. So I'm going to end it here. Control C. Yes. Then Jupyter Lab. So this is a new Jupyter session. Data cleaning. Hopefully it is still clear. Yep. Then I'm going to run all cells. Then we're going to pause it until everything runs and we have our profiling report. Well, pandas profiling has given us a report, and when you look at this report from pandas profiling, it is usually having sections. It is one document, yeah, and this document has sections which you can navigate using this. It's like a dashboard. So we can look at missing values like the chart above, and it is showing you that we have complete values here, but this column here does not have, it's not complete. And remember, it was employment type. Then we can look at correlations, and we can see there, as number one is a high correlation, and you can see there are columns that have very high correlation, like performance CNS score is highly correlated with the description of something. This is not clear. We shall look at this correlation matrix when we're doing machine learning. But we can see there are several columns that are highly correlated with each other, and if you were to do machine learning with this, it will just be adding noise to your data. It's better you have columns that are not correlated, or they are very less correlated to each other. But we shall see how to do feature selection in the next video, when we are building a machine learning model and selecting features. But at least this one, the correlation matrix, is giving us at least a view of how the data looks like, and how these columns are related to each other. And this at least is a good point to note in the future, so that we can be able to see how we can handle this data, so that we don't have a high dimension. And remember, I don't know if you've read about the curse of dimensionality. Yep. So it's good that the correlation matrix, at least it has shown us something that we need to find out how to handle in the future. So those are the correlations. Then interactions. I really haven't known how to use this chart. Yeah, but if you know, you can leave a comment in the description showing me how to use the chart of interactions. Let me go back up so that you can use this navigation bar on top here. So correlations, and then the variables, you can look at this. I have an overview here. We have 233,154 observations. Those are the number of records, or the number of rows in our data set. Missing data is 7,661, which is around 0.1% of the data. That means we can do away with it. But be careful when you're just dropping missing values, because they could be having value, like when data is missing, could be a value, knowing that this person never answered this, and that would add to training of more machine learning. So you need to know how to impute the missing values. So we have numerical columns, which are 28, and then categorical columns, which are 13. Yeah. Then we have here alerts, which tell us this. So this column here has constant value 1. That means there is no other value. And this does not give any, it's not of value to machine learning if the whole column is just 1. So we also need to know how to handle this. Obviously, we're not going to use it when you're training machine learning. So when you're cleaning the data, we're going to drop this column because it's not useful. Yep. So date of birth, and this high cardinality. But I think this date of birth and this other date are not in the format of date, so this could be not important now, but at least this one of unique ID and sorry, let's go back to overview. Unique ID and dispersal date has a very high correlation. We use unique ID to do the counts and stuff, but we can also look at the unique ID and make sure that it is unique. Yeah, it is 100% distinct. This is very important so that we don't have duplicated rows. Let's go back to overview. What else is here? Dispersal amount has a high correlation with the asset cost, so we can use this to reduce our data highly. This is skewed. That means that it could be having extreme values. This one has zeros, 86% zeros, number of inquiries. This one has 92% zeros, which is a good thing to know when you are building machine learning models. So I prefer using this because it gives me a lot of insights of the columns and helps me a lot in categorizing my columns and working with them. So now what I'm going to do is to have my categories of columns. I need columns that are continuous variables. Continuous variables. I also need the columns that are ID, just ID variables, because sometimes IDs don't have value, but sometimes they have. For example, if you have supplier ID, could be of a very good value to you. Then dates, then I need Boolean variables. So bool variables. I'm going to pause the video here, then I fill all this, then I get back. Yeah, I was right to pause the video. It has taken so long. So what I was doing is I would go back here into the variables, and then I look at the variable and decide if the variable falls in the categories that we have put down here. And the first category is continuous variable, then we have ID variables, then we have dates, then we have Boolean variables, then categorical variables, then nominal variables, which nominal is still under categorical, and then other continuous variables. These are variables that are weird in some way. Yeah, but they are continuous. So we are going to, these weird variables, I'm not going to work with them. I think I'm just going to drop them because I could not get the interquartile range from them, and they were just so weird for me. And anything that looks weird for now, since it's the beginning of the project, is not important. Yeah, so the reason why I've categorized them into these categories, those columns, is so that I can handle category by category at once, not column by column, because if I was to handle column by column, this video is going to be like 2 days or 2 days video. So we are going to do cleaning of other continuous variables. So let's start with them. This one here that were weird. And mostly what I'm going to do is to drop them. Other continuous variable, this column should be marked down. So data, other continuous variables. Yep, so let's describe this. So when you look at this. You can see that the the value is highly skewed, and most of the values are around 0, and this is like a million. And if you like get the difference between the 75th percentile and the 25th percentile, you get that 0. So that's why it was just looking weird for me. And these variables are the ones that I'm going to drop. Also, the first part, when I was recording this video, I've just realized that the data here has changed. So I'm likely going to share this old data set on my GitHub. No, I'm not going to share. Let me just show you, then you can still visit here and clean it in another way, but at least you'd have learned something from this video. I think I'll just share the data that I've used, only the train data set, but I will not share the rest of the data set, so that at least you can follow along with this tutorial. Hopefully Kaggle will not come for my neck. Okay, if they tell me to take it down, then I will take it down, and then I will put the feedback in the description, so that you know whether the data is in the repo or it is not. Now let us clean continuous variables. So these are numerical and continuous. They're like real numbers. That's what I'm calling continuous variables. So when you do data and then we do continuous variable, then we look at the head, they look like this. So what we're going to do first is to remove outlier. I'm not going to start removing outlier one by one and looking at the charts. I'm just going to use percentiles to remove the outlier. So I'm going to create a function, and the function that I'm going to create in this notebook here called libs. So we're going to define remove outlier function. Is this clear? Let me check from the record here. Yeah, I think it is clear on your side. Just make it bigger. The bigger the better. So remove outlier. Then data set. The best way to remove outlier is to look at feature by feature, but if you have lots of features and you don't have time, then you can use percentiles and quantiles to remove outliers if they're there. So the first quantile is going to be data set, then that column feature dot quantile, and I want the 25th quantile, that is 0.25. Then the third quantile, that will be 0.75. third quantile, then the interquartile range will be the third quantile minus the first quantile. So we need now to get the lower limit of the data and then the upper limit for that specific feature. I'm going to get the first quantile because I don't want to like go 25. If I was to just use the first quantile and the third quantile, I would lose 50% of the data, because if I get the data that is from the first quantile up to the last quantile, that is just 50% of the data set. And then if I filter it through that, I would lose like 50% of the data. So what I need to do is to get the lower limit and the upper limit for the data set, and at least that will help us eliminate the outlier. So my lower limit is going to be my first quantile minus 1.5. I've done lots of try and error to come up to this interquartile range times plus when you look at the same thing, I found that when you look at the code here, when you look at people who share their code in the notebooks, you'll find that this is what they do also. Upper limit is going to be my third quantile plus 1.5 times AQR. So whatever is outside this, it's an outlier. So it's like mostly we have moved, this is Q3 plus, moved above Q4 and Q0. And if you're below Q0 and you're above Q4, then you must be an outlier. So our data set, our new data set will be equal to our old data set where our data set feature is less than the upper limit, and also we need the data set to be greater than the lower limit. And that is how you eliminate the outliers automatically. This is, you can use this function if you have so many columns. In our case, we have more than 40 and you don't have time. So in our case, we have less than 2 hours to have this video out. So I'm going to run libs inside here. Then run libs.ipnb. So when I run this, I can access the functions that I create in the libs, and this will be okay if the data comes and we want to remove outliers. Obviously, we are not going to remove outliers in production. If there is an outlier, we shall do the scaling, but at least we can know how to remove outliers next time, and we can use this in some other projects. So that's why it is in the libraries. but there are some other function that will be needed in production that we'll put there. So run this, run that, then scroll down. So continuous variables, this is how they look like. What we're going to do now is to remove outliers. So I'm going to say, I'm going to remove this. Then I'm going to say for feature in continuous variables. So for each column in that, our data will be equal to remove outlier function. We pass in data and we pass in the feature. So for each feature, it's going to remove outliers, then provided they're in the continuous variable. So run that, invalid from, not so it's supposed to be for, not from. It's a loop, it's a for loop. So let's see what happened. Data.shape. We see how much of the data we have lost. So here we have 123, 739, and originally when you look at where's the report? The report here, and look at an overview. We had 233, so we have lost like 100,000 observations, but they had outliers, so hopefully it's not going to hurt us a lot. Yeah, but at least we're sure that we are not going to, our data is not going to, our model is not going to be influenced by extreme values. Then next, what we're going to do is now, when you look at the data, let me just do this, then continuous data, continuous variables, dot head. When you look at this, they have like an asset cost is like 584, 58,400. There is 89 here. Some of these values are big, some of these values are small. There is a 0 here. So what we're going to do is to scale all these values to fall within 0 and 1. And to do that, we are going to write a function, because again, that function may be used in production to scale the values. Plus, if there is a maximum disbursed amount and the minimum, we also need to save them somewhere here, so that it will help to check extreme values and also scale values when they come, when you're pushing your model to production. So now we are going to write a function that is going to help in scaling continuous variables. Or you can use the models that are in sklearn that you use to scale, but I like sometimes to have control on what I'm writing. I've said sometimes if it is a simple function. So scale continuous, and what we need is a series and the feature. Series is just a pandas column. Then we need from the series, we're going to get the maximum values. So maximum is going to be series.max. Then minimum is going to be series.min. Then our series range is going to be maximum minus minimum. Right, so what I'm going to do is, because I want to save for each feature its maximum value and the minimum value, because we need to save that. It may be useful when we are pushing things to production. So I'm going to just call this feature min max. I will need to save this somewhere. So I'll just put it as a list. Then I will append the maximum and the minimum and the feature inside it. So this dot append and what we're going to append is the feature, the maximum value, and the minimum value. Then we are going to return the scale value. So return series dot apply. So we're going to scale the whole series. This is just the pandas series, so we can use apply. The pandas apply lambda, so that value, and then we are going to use the value minus minimum divide by the series range. So this will make sure that our value is within 0 to 1, because we're getting that value for that column minus the minimum for that column divided by the minimum maximum minus the minimum. So the values will always be positive, and there will be bound between 0 and 1. Plus we are also saving the minimum and the maximum in case we have our model in production. The developer who is going to push our model to production can use the minimum and the maximum to return, for example, error or comments that this column had values that are greater than the maximum value that was used to train the model, so that, like a warning, so that whoever is consuming the model knows what's happening in case maybe the model is returning wrong answers. So we are going to go back here. We're going to run this again. I'm going to save this so that when I run it, it contains the function and everything within. So I'm going to run this. Then after running that, we're going to scale each value. So here for feature and continuous variable, we are going to do the scaling. So we'll say data feature will be equal to scale continuous and data feature. And when we run this, when we do again data dot head, data, then we get the continuous variables, then we do dot head. We have now all of them are positive values and they're within 0 to 1. So our model will not be explosive and it will not take so long when it is calculating values if the data is so big, because the the values are bound between 0 and 1, so it takes shorter period. If it was like working with millions, then it will take long to do multiplications. Yeah, so that is how we are going to work with this automatically. We also need to save our minimum and maximum values. Where am I? So if you do remember this this list we created here, after running that function, that list will contain stuff. So when you run this, you see it contains this, which we need to save because this burst amount, this is the maximum value, this is the minimum value, this is the maximum value for asset cost, this is the minimum value for LTV, this is the maximum value, this is the minimum value, and these are the values that I used to calculate them, the values that we are seeing here. So we need to save this for the purpose of production. So I'm going to do my data frame is going to be equal to pandas dot data frame, and then feature min max, then the columns, I'm going to say their calls, and my variable of calls is going to be here, so that we can have the column names. So it is feature, then there is min value, then there is max value, yeah. So this is going to be that data frame, and then we're going to say to change the index because I want to save it as JSON, and you'll see what will happen when I save it as JSON. So the data frame, I want the index to be the feature. Index should be data frame dot feature. Then I'm going to delete data frame feature. Then I'm going now to save that data frame to JSON. And the JSON is going to be called features min max dot JSON, and the orientation I want should be index. So orient equals to index. There are several orientation like record and stuff, but now I want index so that each feature is related to its minimum and maximum as dictionaries. Yep. So this, let's run this. When you run that, it creates that file here. It has created, yeah, it's here. So I can open this. This is why I like Jupyter Lab, because you can open any file and you can see root. When you see these values here, so these are the names of the features. The reason why they're here is because I oriented them like index. I made them index here, and I made the orientation to be the index. Then when you open any of them, you'll see the minimum value for it and the maximum value. And these now can be sent to the data engineer or the machine learning engineer who is going to push a model to production with some instructions. Right. So that's how we handle the continuous variable. It's mostly scaling and removing outliers. Next, we're going to work with dates. So the dates, where are you, dates. So what should we do with the dates? Let's first look at the dates. Dates. I don't know if the data type is dates. So let's look at .d types, I think. Yep. So they are objects. We need to make them dates. So we're going to do this. We know there are two columns here. I'm just going to put them here so that we can see their names. It is date of birth and dispersal date. We're going to make them dates, and we're going to, not like for date of birth, we're just going to feature engineer the age of the applicant, then the dispersal date. We're going to look at dispersal age. I'm going to delete the date of birth because after getting the age, I don't think there is something else I need from the date of birth. But dispersal date, I will leave it because it may be important when we are splitting the data into training, testing, and validation. More so for the validation bit, because we can sort the data based on the dispersal date. Then after sorting it, we can take the most recent data as a validation set. Then the training and testing can be the data that is not most recent, and we can use the dispersal date to do that. So let's first make these ones dates. So date of birth, we're going to do data, then date of birth should be equal to data date of birth, and we're going to change this to date time. So pd dot to date time. The same as dispersal date. So when you run this, it has these weird warnings. I really don't like warnings. I think warnings are only important when there are errors. I usually say that, so I'm going to ignore all warnings in this Jupyter notebook. So I'm going to import warnings. Then I am going to say warnings dot filter warnings. And when we are filtering warnings, we just ignore. Right, so when we go back here, and run this. Nice. So when you do data dates, then we do dot d types, they are now date time, which is now at least the format or the type that we want the dates to be. So now we are going to engineer this feature. Data applicant age is going to be we need the date today minus the date of birth. Then we're going to want the age in years, so we're going to divide by 365. Yeah, and so forth. So and make that a day. So let's and get the days. Yeah, so let's do that. So we're going to get today's date. I think I should put it here. Today's date is going to be date time dot today, but we don't have date time. We're going to import date time here from date time, import date time, run that. Then we go here at the end here, then we run this. Right, so now we're going to do the date thing. So the applicant's age is going to be date minus date of birth, and then we are going to divide this by 365. My computer is hanging, I don't know. Divide by 365. Then this we are going to dot apply, and we only get the days in as a float. So dot apply lambda x, then float x dot days. Going to make this go to the other line. Tab. So x dot days. We run this. Then when we try to look at applicant's age, dot head, this is 38, right? We are going to do the same for dispersal age. So I'll just copy this and I put this bar. So age should be dispersal date. Voila. So we don't need date of birth anymore, but we'll need the dispersal date. So I'm going to delete the date of birth. And that's the end of the dates cleaning. Next, we are going to work with the nominal variables. I think it is now the right time to call for pee break. Can go take a pee, have some water, then we continue with the is this a lesson? Is this a lecture? Is this a tutorial? We continue with what we are doing, something, having fun with data. So take a pee break. Yep, hopefully you've taken your pee break. Let's continue. Now we are going to work with the nominal variables. Let me go back. I'm going to like hide the output for this because they take long to scroll. These outputs that are large. Okay, so now we can scroll, and yeah, so we have seen continuous, we have seen dates. Let's work with the nominal. I'm going to hide this. So the nominal variables, if you want to see who they are, they're those four variables. We're going to start with the employment type. So data, this employment type. Yep. I'm going to look at unique and I see how many categories it is also a categorical variable, not unique, it's unique. So I am seeing a none. Yeah, I had forgotten that it is employment type that had missing variables. Yeah, so not a number. Okay, so we shall see what to do with this. There is this. So what we need to do here is to encode this. So I'm going to write a function that's going to be encoding this inside the libs, and I'm going to call that function encode employment type. So I'm going to define it here. Define encode employment type. By now I think you know why I'm doing this. Is because if we are pushing this model to production, we can easily, when someone says sends us data as a record and it has salaried, we can just call this function and encode it there and then, so that we don't repeat ourselves in production. Also, this project I'm going to run it until we reach production. We shall build an API for it. So we expect a value, and then we're going to return a string, and we're going to say if that value is np.none, if it is a missing value, we should return. So I'm just going to encode missing values with 0 for this column. I don't know if we have imported anything in this file, but I'm going to import here. Import numpy as np. So if it is a missing value, it should return 0. If that value, I'm just putting a string around it to be sure that it is a string. If the lowercase of that value is salaried, was it salaried? Yeah, salaried, self-employed. So if it is salaried, we return 1. the string of that value dot lower is this one. I'll just need to copy self-employed. Then we return to else we are going to raise an exception. Value error. Then we're going to say an expected employment type. If this function is put in an API, we are going to raise a HTTP error so that the error can be sent back with the return value. So let's apply this in that column. But before we do that, we have to run the cell again. Then we go back here and we are going to apply that function to employment type. So I'm going to remove this, say apply that. When I run that, it's giving me an error. Lower, name lower is not defined. Yeah, not slash lower, it should be dot. So let's go back, run this cell, then I come back and I run this. Well, we can see now, instead of giving us the values that we're seeing, salary, done, none, we're getting 1, 2, like that. So we're just going to update this column equals to that. The next column is this one, perform CNS score. Perform CNS score is, I saw it was correlated to a certain column, which is perform CNS score description. Yeah, so we have here this description. I saw another column called just perform CNS score, and I want us to look at how these columns are related and whether we need to work with both or just one. So when you do this dot unique, there are so many. At first I thought I would just code these ones and zeros, but we may not need this description at all because we already have the score as a numeric value. So let's work with that. So we're going to do data dot group by. What I want to do is to look at the minimum and the maximum values for perform CNS score, and I see if there is an intersection between two or more descriptions. So we have perform CNS score as a column. We can look at here and confirm. There is perform CNS score here, and then there is perform CNS score description somewhere here. Yeah, not here. Perform CNS score. We are working categorical variables. There is perform CNS score description. So let's look at the maximum and the minimum value for each description. So we're going to group by perform score description. So when you have these groups, we're going to aggregate the perform score, and the functions that we're going to aggregate with should be the minimum and maximum. So we're going to do dot aggregate, and the column we're aggregating is perform score. I'll just copy here. That's the column. Let me just push this to a new line. So this and the functions, I need them to be in two columns. So we're going to use np.min, comma, np.max. So we're going to have the minimum and maximum. Yeah, and I also want them to be sorted. So we're going to have dot sort values in a data frame. And we're going to sort values by perform score and the minimum values. So we're going to sort first of all by this perform score. Then we're going to sort by min, just the minimums. So when you run this, it is saying that we have syntax error here. Just want to confirm with my notes. Yep, something is missing here. Yep, it is a dictionary. This is the key and this is the values. Right, so now we have, this is perform score and this is the description. It's a categorical variable, this is a continuous variable, and we've already worked on this, and we have the minimum and the maximums here. You can see this one moves from, this just one value, and then when we look at this, it's a value, the minimum of this is a value bigger than this, so it is, these are just buckets of these values. So these descriptions are buckets of the perform score. I don't need this because I have these values which can be used, so I'm going to delete this column. So we're going to delete data, that. Then this is a very long stuff, I'm going to hide it. Yep, so let's run this. The next column we are going to look at, let me hide this, is going to be the credit history length. So data, not perform score, that is done, credit history length. Yeah, so this dot unique, this can be made continuous. It has years and months. I think you can write a function that extracts the number of years from this text, and I think we are going to call that function clean age length string. So let me create a new cell here. We define a function called clean age length string, and clean age length string is going to take, I'm just going to call this history, as a string, and it should return a float. And then if history exists, if that value exists, so we're going to split history. It's going to be history, so here we're going to split it by space, and it will give us a list. So what we're going to do here is, for a value like this, we split it so that we have 1 year and 2 months in a string. So what you expect this to be now is going to be a list of 2 strings. Then we get years is going to be, I'm going to make it a history. The first value is the years. Then I'm going to do dot lower to make it lowercase. Again, and then we're going to replace years with nothing. So this will give us a string. When we replace years with nothing, we remain with just that value, but as a string. So we're going to convert this into an integer. And then the value that we have here will be years in integer. So we do the same for months. And the value for months is the second value. We're replacing MON, month, and it is that. Then now we need total years. So the total years will be years plus months divided by 12, because a year is a month. A year has 12 months. We just want to return years, so it will be like 1.5 is a year and 6 months. Then we return total years. Right, save this, go back here to data cleaning, run this cell, come down, baby, come down. Then we're going to apply it here. So dot apply, can't remember the name of the function, clean age length string, and run that. Have 0 0.0, 0 0.02. Yep, so this is going to be equal to that. Right. So we have credit history length. The next column is average account length. So we're going to do data average account length. Oh, it is the same as this, so this is easy. We will just copy this. See, when you create a function, it becomes easy for you. You don't repeat yourself. Average account length is here. Then run this. So what is our data looking like? uh, we deleted a certain column. So yep, we can maybe look at what this one is looking like. That head, yeah, looks like this. So this is 1.75 years. I think that is all to do with the nominal variables. Next, we're going to work with the Boolean variables. So the Boolean variables were these ones. And we'll need to look at how they look like when we make them Boolean. Mostly for this is data Boolean variables dot head. They have ones and zeros. We just make them Boolean. And how do we make them Boolean? We just change their types. So I'm going to do for column in Boolean variables data column is going to be equal to data column dot as type Boolean, that is bool. And that's it for that. We could maybe try to look at which column it's working on, and we also need to print the unique value so that we are sure that it's a Boolean value. Data call that unique, then we run. So we are seeing mobile number aerial flag is having only true values. This is the one that we saw in the report that had only one, which I say that is not important. We can just drop this, we don't need it. This has true and false and the rest. So the next thing we're going to do is just to delete this column because it is not useful until it becomes useful in the future, for example in the company, but for now it's not useful. So that is how we clean the Boolean variables. I could want to, there is one category of variables that I have not cleaned, the ID variables. I wanted at first to drop them, but I feel like when we are building the model, they may be important. For example, supply ID, manufacturer ID could influence. Like you may find that the cars that are coming from Toyota, people are paying well and then they're not defaulting, or Tesla, people like them so much and then they can't default paying them, but maybe some other brand or manufacturers, people get frustrated with the vehicles and then they start defaulting paying. So like that's where the car is coming from. Maybe the supplier didn't maintain it well. Or maybe the supplier does not remind the client to pay and then they default. There are so many things that you can use here. They may or may not be important when you're building the model. So that's why we shall do some bit of looking at feature importance and whether these features are going to be important when we are building our model. So I haven't worked with this. Those ID variables, but I think they may be important, even the state where the people are coming from. It's very important for you to be careful when you're looking at these things to do with where someone is coming from. For example, the state, like the state ID, because now the model may be biased, and also the gender. If you're training a model and you've put males and female into your model, and you've not analyzed to see that there is a balance between the people who are defaulting for both males and female and people who are not defaulting for both males and female, and you find that one gender is um, having lots of people who are defaulting, then your model is most likely to be biased towards the gender. So you must have to be very careful. We shall do an analysis of the state because this is where someone is coming from and see if the data is balanced for all the states. If it is not, it may be biased towards where someone is coming from and it's not going to be important. Yep, so let's look at our data. And this is how our data is looking like, at least for now. I was wondering why we have a very big value. It's just an ID. Dispersal date, I told you we're leaving it here so that it can help us to create a validation set. Primary install amount, secondary install amount. These are the weird columns I was talking about. Why didn't I remove them? Primary install amount, the other variables. We don't need this weird variables. We're going to data equals to data dot drop, and these are other continuous variables. Axis equals to 1. You found out that when I'm dropping or deleting one column, I just write delete, but this is a way of deleting so many columns. After doing this, I'm going to run all the cells. It may take time. No, I'm not. I'm going to run, but I'm going to skip one cell, the one of report, so that the describe will not take long. This profiling is the one that will take long, so I'll not run that. I'll run the rest of the cells. Right, so we have this. This is our output. We are going to create our final data frame, and I'll make sure that all the columns are in uppercase or lowercase, depends. So columns will be equal to call for call in data dot columns, but I want this to be in uppercase. Then data dot columns will be equal to columns. Then we can now look at the data dot head. You can see all the columns are uppercase. You may want to make them lowercase if you're working with databases, but since we got our data with most of the columns in uppercase, if not all, we should also have our data because the JSON may come with the keys in uppercase, so it will be easier for you to work with. Then let's save this data. So data dot to CSV. We are going to save it where? I'm going to save it in this folder called data. And I'm going to call it clean data.csv. Clean data.csv. I don't want it to be saved with the indexes, so index equals to false. Yep, so let's also look at the shape of the data. We are saving 123 records and 34 columns. It is already saved inside data here. You can see clean data. It saved in seconds ago. and this is more clean, this is ID, than the way it was here in train. So if we compare the train, the values were like this, but in clean data we don't have numerical values. So this is all to do with the data cleaning, and I'm going to push the whole of this to the repo. Also, I said that I'm going to push the train data because it is somewhat different to the current data that is in Kaggle. Hopefully Kaggle will not follow me to say that I am over pushing the data, but we'll also need to write it, the source of the data, in our readme. So let me open the readme and let's see data source will be here. Then after doing this and saving it, and in get ignore, we are going to ignore not everything that has CSV, but we are going to ignore data dictionary, .csv. Yep. Then we're also going to ignore star test.csv. We're going to ignore I think only those two. So inside the data folder you'll find clean data and you'll find the train data. So let's push this to Git, then we shall continue from there. Please consider subscribing because it motivates me when you subscribe anyway. Then wait for the next session, which may be in the course of next week, where we're going to build the machine learning model. So git add everything, then git commit -m cleaning data, then git push. Yeah, so don't forget to subscribe to the channel, and also if you have any comment and suggestions, please put them in the comments below. The link to the code is in the description. Until next time, take care and be healthy. Bye.